Hello, learners. Today we are once again here.
This is not a dream.
Puzzles. We have the cube, the part of the cube here, the Rubik's cube, and we're back to twisting the tail. So here you see we have two questions here that we're going to deal with. We're going to construct it with the pieces, and of course I need my marker. Without it, I cannot do much work. And then I go straight to it. So with my marker handy, I have to remember that this is the equilibrium system. In other words, the balancing point around which all the other pieces move. And what is that? What mathematical symbol is that? Your guess is as good as mine. That is the equal sign. So let's keep the equal sign in the middle here. And as you can see, it's here, right there. It's always important to keep it there. Okay, so we have to start creating our terms. So I have my 2 on 4. So I have my 2 on 4x. So let me use these ones. Yes. So I have 2 here. Yeah, so 2 on 4x. 2 on 4x. And then what else are we lacking? Okay. We have an add-on. So plus, yeah, so this is 2 on 4x plus 2, obviously equal, as you can see, and we create the other side 1 on 4. So here we can still have one of our variables. Okay, so let's still have this one here. So we have 1 on 4. So let's pick one of these. Yep, so that we have 1 on 4. Here it is. So we're done constructing. So 2 on 4, this is the first term, this is the second term. The equal sign is the middle line, this is the third term. So there are two sides, 2 terms here and 1 term here. Interestingly, what is going to happen is that each of the terms, we're going to multiply through each of the terms by the denominator, which is 4, right? So we're going to have times 4, 4 on 4, 4 on 4 will give us the answer 1. So this cancels out, and we have 2x. So we have 2 with x now, right? And it's still oriented in the best possible form for them to be properly aligned. Yes, I think this is far better. That is 2x plus obviously 2 times 4. Yes, so this is 8. Now the next is, well, 4, 1 on 4 times 1 on 4x times 4. Well, we can rearrange it. The x can come this way because they're all multiplying. And so because of multiplication, we're able to, right, apply the commutative property to move the 4 here and the x there. So eventually we get 4 on 4, which will also cancel out, leaving only x. And 1 times x will be x. So this is a story that we have here. So moving forward, we need to group all the green x's on one side and carry all the numbers to the other side. So by moving this to the other side, we have to note that while this exists here, there's no sign with it. And when that is the case, we assume that the sign it comes with is positive. We assume that the sign it comes with is positive. So we're going to assign a positive value to this one here. Because when variables have no negative sign, we assume that the sign they come with is positive. So now we transpose. As usual, this goes to the other side, whilst the number also comes to this side. Just before it comes, it will have to change color to a different sign. It will have to change color, oops, to a different sign. And just before this one comes here, it will also change color to a different sign. So we now have minus x. So it's 2x minus x equal minus 8. And so you would notice that when there's a negative sign attached to a variable, we can assign that as negative 1. There's a coefficient of negative 1. Anytime there's a negative attached to a variable, there's 1 with the variable. Or in other words, the variable appears 1 time with the negative. So all we do now is we simply notice that we can factor this out, because these are common. So you can factor this out and leave 2 minus 1 bracketed. You can leave 2 minus 1 bracketed for us. Yes, you can leave 2 minus 1 bracketed for us. So obviously 2 minus 1, the answer will obviously be 1x. 1x. So as you can see in our equilibrium system, we have 1x is equal to minus 8, but 1x is also the same as x. So instead of saying 1x, you can simply say x is equal to minus 8. And that is the answer to this solution. And if you put minus 8 here, it will satisfy both conditions. So let's attempt that to see whether indeed minus 8 actually functions to satisfy this. Yeah, so we put this here. So let's shift this here. So my question says that 2 into bracket x. So x is minus 8. We are working the left hand side on 4 plus 2. So the left hand side, as you can see, gives me well, 4 goes here 1, 4 goes here 2. 2 times 2 4, so it's minus 4 plus 2, and that will give me negative 2 as the answer on the left hand side. What about the right hand side? Well, on the right hand side, it says it's 1 on 4x. So 1 on 4 into bracket 8, right? And how many times? Minus 8, my bad. So how many times does 4 go into minus 8? Goes here 1, goes here 2, so the answer is minus 2. So you can see that the left hand side gave us minus 2, and that was the same as the right hand side, which is minus 2. So that is why we say that x is equal to minus 8 is a solution to the first problem. So in this second problem, we obviously see that we have the greater than less than sign. What this means is that this side of the problem is bigger than this side of the problem. In other words, this side is bigger and this side is smaller, and that is the inequality we are dealing with. So let's construct our equation. So obviously I need to pick some colors. Which color should I pick? I think I want to go with the orange for my x's. So I have my first x here. That's over here. Let's keep this for this x, and let's keep this for the other x here. And then here does not belong to this. The sign here does not belong to this. So this is 7 taken away from 9 times of a certain number, and it's greater than 2 taken away from 4 times of a certain number. And this is the expression you want to solve. And it so happens that one side of the equation is always bigger than the other side. In other words, it's like there's a tilt. It's like there's a tilt to one side, and the tilt favors this side, the bigger side, and this is the smaller side. So let's proceed to see how we'll go through this problem. Obviously very simple. I need to group like terms. So this and this are similar terms. It means that I have to remember the opposite sign that we come with, which is addition here, and then the opposite sign that this comes with is addition too. Yes. So how about this? We need to keep one sign handy. So the green obviously is positive. The reason why we need a positive here is that we're going to take it across the equal sign. So we have to recognize this sign before we take it away. So like I said, this belongs to this belongs to this. Even though it's invisible for now, we'll bring it back. So when we're grouping like terms, I want to take the 4x to the other side to join the bigger one. So as I move it, I have to recognize that it's positive now. So by moving it this way, the sign will change. The sign will change from positive to negative. So it becomes negative and then comes in. Whilst this one goes to the other side, just before it lands, it will have to turn itself to positive. Yes, that's the inequality stands. So as long as this transposition occurs, the inequality still stands. So as you can see, we have 9x minus 4x. Then right now, the negative 7 came to be positive here. Well, of course, we can add it onto this too. We can add it onto this to make it negative 2 plus 7. Then we can also reverse it and make it 7 minus 2 and ignore this for now. So that the answer to 7 minus 2 will be 5. And then what will the answer now for this case? As we always say, the x is common, so it's like we can factor the x out and solve 9 minus 4. So that we're not going to multiply, we just need one term of it, whilst this work together to give us one number, which is 5. So 5x, and obviously a simple procedure to go through is to divide both sides by 5. So dividing here by 5, dividing the other side by 5. This will cancel, and it will also cancel out. But here, the figure that will be left will be 1. Of course, when we cancel out, there will be 1 also here, but 1 times x is also 1x, but 1 times x will also give you x. But here there's nothing to multiply the 1, so it's essential we keep the 1 as our answer. So what this solution means is that there isn't only one number that satisfies this equation. The numbers that satisfy this equation are greater than or equal to 1. So they start with 1, and the next on the bill will be what? The next number that will satisfy the equation will be what? 2. The next number that will satisfy the equation will be what? 3. So as long as it's positive, even sometimes even if it's decimal, as long as it's positive and greater than 1, 1, 2, 3, and it continues, yes, it will satisfy this equation. So any number, as long as it's greater than 1, will satisfy this equation. It means that if the number is less than 1, this equation will be wrong. So let's test that to see whether if it's less than 1, this will go wrong. So we know that x should be greater than 1. So what about if we make x to be 0? So in that case, 9x minus 7, which is the left hand side. That's 9, 0, minus 7, that's minus 7. Okay, what about the right hand side? which is 4 into bracket 0 minus 2. This 0 minus 2. This minus 2. So this is then saying that 7 is minus 7 is greater than minus 2. Now this statement is not true. Net minus 7 is not greater than minus 2. So this is not true. So you can see that if you choose a number which doesn't satisfy this condition, the equation would not be satisfied, or the inequality will not prove true. So this is the solution, and these are the numbers. Number is greater than 1, greater than or equal to 1. It can be 1 or greater than 1, and it will satisfy this inequality. So thank you very much for supporting the channel. Don't forget to drop your code to get your Rubik's Cube, and I'll be coming soon to your schools. Tell my parents I've got your couple of names from there, beautiful, and also the other schools that are requesting me to come. We love the support that you're putting onto the channel. Thank you. See you soon.